Good morning, class. My name is Logarithms, the CEO of Market Tutors. You are welcome to SS2. Welcome to SS2 class. Good to see you. Today, we are going to be looking at logarithm of numbers greater than 1. Logarithm of numbers greater than 1. So, after this, let's look at what we mean by logarithm. At the end of the lesson, students should be able to recall and express a given number in standard form. You should be able to recall and express a given number in standard form. You should also be able to record the use of logarithm tables to perform calculations involving numbers greater than 1. You should be able to recall the use of logarithm tables to perform calculations involving numbers greater than 1. Now, what are logarithm tables? These are also called four-figure tables. You should also be able to use logarithm tables, which is four-figure tables, to perform calculations involving multiplications, division, powers, and roots of numbers greater than 1. We're still going to look at numbers less than 1. So we're looking at these operations, multiplications, division, powers, and roots of numbers greater than 1. Let's go on. So before we look at logarithm, we need to know what standard form is. Standard form is just a short way of expressing large and very small numbers. It's a short way of expressing large and very small numbers. What do I mean by this? Numbers that are very, very big, in billions, trillions, and also numbers that are smaller than 1 or very, very small. We can use standard form to represent them. Now, how can a number be represented in standard form? A number is said to be in standard form if you can express it in the form a times 10 raised to the power n, where a is what? Where a is a number between 1 and 10. A is a number between 1 and 10. So any number that must be here must be a number between 1 and 10, not 1, not 10, but a number between 1 and 10, and it can be decimal. Then n is what? N is a positive or negative integer. Positive or negative integer. Integers are whole numbers. So let's go on. Look at examples here. Write the following in standard form. 367. 367 is 3.67 times 100. How did I get this? Now, you assume there's a decimal point here. Shift the decimal backward in such a way that what you are going to have will be a number that is less than 10. 367 is more than 10. If you say 36.7 is also more than 10, the number that is between 1 and 10 will be 3.67, which is 3.67 here. And because you shifted the decimal backward 2 times, it's going to be times 100. So an 100 is what? It's 10 raised to the power 2. So your answer is 3.67 times 10 raised to the power 2. Same goes for 4789. By the time you shift the decimal, it will be 1, 2, 3. You have shifted the decimal 3 times backward. So that means 4.789 times 1000. So you shifted the decimal 3 times backward. So and 1000 is what? 10 raised to the power 3. So your answer is 4.789 times 10 raised to the power 3. And you see that 4.789 is a number that is between 1 and 10. 3.67 is also a number between 1 and 10. So we are right. The same goes for 607.89. How will you get a number less than 10 here? It is when you have 6.0789. And how many times did you shift it? You shifted it 2 times backward. That's times 100. And 100 is 10 raised to the power 2. So all these are the ways in which you can do what? You can get or express numbers in standard form. Let's look at this number 5. This number is a number less than 1. How do we solve this? Shift the decimal to a position where you can now get a number less than 10. So let's shift it. 1, 2, 3. So it is 9.87. How many times did you shift it? You shifted it 3 times where? Forward. So that means it is divided by 1000. 3 times forward is what? Divided by 1000. And 1000 is what? 10 raised to the power minus 3. So it will be 9.87 times 10 raised to the power minus 3. And that's how you are going to go on and on to do this. Let's continue. So let's now look at logarithm of numbers greater than 1. What do you understand by logarithm? Logarithms of numbers can be obtained from four-figure tables, which is the same thing as what? Logarithm tables. And logarithm is divided into 2, characteristics and mantissa. the whole number or the integer part, the one without decimal, the one that comes before decimal is the whole number, is the characteristics. And the one that is after the decimal is called the mantissa. The decimal part is called the mantissa. So logarithm is very into characteristics and the mantissa. Let's look at an example here. Use tables to find the logarithm of 850.9. Logarithm of 850.9. 850.9 can be written in standard form as 8.509 times 100 because you shifted this 2 times. So times 100. And 100 is what? 10 raised to the power 2. So, but when you look at 4-figure table, the log of 8.509 is what? Is 0.9299. That is from the logarithm table. So your 8.509, which is this, 8.509, will now be what? Will now be 10 raised to the power that logarithm that you be able to get from 4-figure table. So it is 10 raised to the power that number times 100 is what? Is 10 raised to the power what? 10 raised to the power 2. So 8.509 will now be 10 raised to the power 0.9299 plus 2 because this is in form of indices. And in indices you add together. So if you add 0.9299 plus 2, 2 is what? 2 is the same thing as 2.0. 2.0. So when you add this together, you're going to have 2.9299. So the log of this is going to give you, the log of 850.9 will now give you what? 2.9299. Another method you can use is this. Now you are to find the log of 850.9. What is the characteristics of this number? How many numbers do you have before the decimal? You have 3 numbers, 3 digits. 1, 2, 3. So the characteristic has what? 3 digits. So the rule is that you subtract 1 from the digits. So 3 minus 1 will give you 2. Then you now go to your 4-figure table and check 85 under 0 difference 5. Difference what? 5. So 85 under 0 will give you 85 under 0, then difference 5 will give you 0.9299 from 4-figure table. So what you just need to do is to say, okay, that 0.9299, add it to what? To 2. Which 2? This 2 that you arrive at here. And that will give you 2.9299. Now let's look at antilog now. Antilog is the opposite of logarithm. Antilog is the opposite of logarithm. Now this example says you should find a number whose logarithm is this. That means indirectly find the antilog of this number. Find the antilog of this number. So what are the steps? Find the antilog of 1.8385. Now what is the characteristics? The characteristic is what? Is 1 because we have one number before the decimal. So it is 1. That is 1 digit. And the mantissa is what? Is the number after the decimal, which is 8385, which is 0.8385. Now from your anti-logarithm table, in 4-figure table you have logarithm, antilog, and so many other tables there. So now let's open to anti-logarithm tables. When you open to anti-logarithm tables, the number corresponding to 0.8385 is what? Is 6887. 6887. So 83 under 8 will give you 6887. Then difference 5 will give you 8. And when you add it together, you have 6895. And since the characteristic is what? Is 1. For antilog now you are adding 1 to it. So add 1 to that characteristic, it will now give you 2. When it gives you 2, then you now write your what you arrive at on the antilog table, which is 6895. And since what you now have after adding 1 is 2, that means you count 2 numbers from the front here. 1, 2, and put your decimal. And so you now have 68.95 as the what? As the antilog of 1.8385. Okay, let's go on. what are the rules for the use of logarithm? If you have any numbers that multiplies each other, the rule is that you must find the logarithm of the numbers and add them together. If you have numbers that are dividing each other, the rule is that you find the logarithm of each number, then subtract the logarithm of the denominator from the logarithm of the what? Numerator. We're still going to look at an example. Then if you have any number that is raised to a particular power, you find the logarithm of the number and you then multiply it by the power or the index. So if I have 2.3 raised to power 5, I find the logarithm of 2.3, I will now multiply that logarithm by 5, where it's raised to power 5. Which is raised to power 4, I multiply the logarithm by 4. Then the fourth rule is under roots. If you have any number that is square root, cube root, fourth root, and so on, the rule is that you find the logarithm of the number and you divide it by that root. If it is square root, you find the logarithm of the number and you divide by 2. If it is cube root, you find the logarithm of the number and you divide by 3. If it is fifth root, you find the logarithm of the number and divide by 5. So in each case, to obtain your final answer, you have to find the antilog of the result. Okay, let's look at this example now. Example 1. Evaluate using 4 figure tables. 19.28 times 2.987 times 195.8. So you set your table like this, number, then log. Since what you have here, everything here is what? Multiplication. So the rule is that you write the number, the three numbers they are here. Then you know how we arrive at the logarithm here. We have two numbers here as digits, as characteristics. 2 minus 1 will give you 1. So that will be 1 point. Then you check on your 4 figure table, 19 under 2, difference 8, add them together to give you 2851. The characteristic here is what? 1. 1 minus 1, 0. You put 0 here, point. Then 4 figure table, 29 under 8, difference 7, add them together to give you 4752. Then here the characteristic is 3. 3 minus 1 is 2. So you have 2 points. Then 4 figure table, 19 under 5 difference 8 will give you 2918. Then add all these logarithms together to give you 4.0521. Now, what are you supposed to do here? Since you have 4 here, the rule is that you add 1 to it. So 4 plus 1 will give you what? Will give you 5. So that means you're going to have 5 numbers here. You're going to have 5 numbers here. So then you check on your antilog table. 0.5 under 2, 0.5 difference 2, or 0.5 under 2 difference 1. When you add everything together, it will give you 1127. But 1127 is just 4 digits, and you have 5 here. After adding 1 to it, you have 5 here. So you have 5 here. So that means you're going to add a 0 here to make it up to what? To 5 digits. So you now have 11270. So now be up to 5 digits. But it must be 5 digits. But you have 4 here. So after adding 1 to be 5. So what you have here must be up to 5 digits. Must be 5 digits. And that's why we added 0 here. So let's continue. Once again, my name is Galakija, the CEO of Matic Tutors. Example 2. We are to evaluate using 4 figure tables. 189.7 divided by 34.8. So set your table. You have the two numbers here. 3 digits. 3 minus 1 is 2. That's 2 points. 2 digits. Characteristic is 2. 2 minus 1 is 1. 1 point. Then 18 under 9 difference 7 will give you 2781. 34 under 8 will give you 5416. And you have to subtract because this is division. So you must subtract the logarithms. And when you subtract, you get 0.7365. So you are going to add 1 to this 0 to this 0. When you add 1 to this 0, it becomes what? It becomes 1. Then you now use your antilog table to find 73 under 6 difference 5. And that will give you 5451. So you have 5451. But the number here is 1. So that means after the first number, you put your decimal from the front. Then it will now be 5.451. Let's go ahead. Example 3. This has to do with what? Roots. 50.64 raised to power 5. And from the rule, anything that has to do with power, you have to multiply. So 50.64. The characteristics is 2. 2 minus 1 is 1, so you have 1 point. Then from your 4-figure table, logarithm, 50 under 6 difference 4 will give you 7045. And because it is raised to power 5, you multiply 1.7045 times 5, which will give you 8.5225, which is what you have here. Now, by the time you now add 1 to it, it becomes what? It becomes 9. So, let's find the antilog of 52 under 2 difference 5. Antilog of 52 under 2 difference 5 will give you 3331. 4 digit, 3331. But because you have 9 here, you have to make it up to what? Up to 9 digits. So that means, since you have 3331, which is 4 digits, we're going to have add 5 zeros to it. So when you add 5 zeros to it, everything, all the digits now becomes what? 9. Another one here is what? Example 4, which has to do with what? Roots. So 605.8. This is fourth root. That is, fourth root means the number that you multiply by itself 4 times, that will give you 605.8. So the characteristics is what? Is 3. 3 minus 1 is 2. That's 2 points. Then 60 under 5 difference 8 will give you 7824. And because it is fourth root, we now divide 2.7824 divided by 4, and that will give you 0.6956, which is what you have here. And don't forget that you have to do what again? Add 1 to this. When you add 1 to it, it becomes 0.1. 0 plus 1, that is 0. 0.1, sorry, which is what? 1. Then, what is 69 under 5 difference 6 from antilog? 69 under 5 difference 6. That will give you 4962. 4962. And because you have 1 here, so that means after the first digit from the front, you put your decimal. So your answer will be 4.962. On the last slide now, you have this 508.6 raised to power 3 times this square root of this number. Everything divided by what? 7.95 raised to power 2 times cube root of 9010. So you have some numbers on the numerator. These numbers on the numerator will be placed here. Then you have numerator. The numbers on the denominator will be placed here. Then you have denominator. Then you find the antilog of 50 under a difference 6. Sorry, the log of 50 under a difference 6. Then multiply by 3 because it's raised to power 3 to give you this. Then log of 87 under 1 difference 0 will give you 4.9400. You divide it by 2 because it's a square root. It will give you this. Then you add the logarithm. It will give you 10.5892, which is what you have here. Do the same thing for the denominator. 0.9004 raised to power 2 will be times 2, which is equals to this. The cube root of this will be the log of 9010 divided by 3 will give you this. Then add them together will give you 3.119. You put it here. Then because of this long division, you subtract to give you 7.4702. And when you now find the antilog of 47 under 0 difference 2, to give you 2953. But because this is 7 here, and when you add 1 to it, it will give you what? It will give you 8. So that means you are going to make it 8 digits. And already you have 4 digits here, 2953. So that means add 4 zeros to it to make it up to what? So 8 digits. Exactly. So if you have any question, you can visit us on our website and also on our Facebook pages. Thank you.